So hello and welcome everyone to yet another Be Waste Wise webinar this month. I'm Akanksha Singh. As most of you all know, I'm the community builder at Be Waste Wise. And before we proceed with the webinar discussion, we wanted to give you a brief intro on our organization. We are a non-profit organization and we've been holding such waste dialogues on monthly basis, addressing the need for knowledge dissemination on waste management since 2013. It's been over a decade that we've been bridging this waste solutions expertise gap worldwide. And if you see the value in making such diverse sustainability dialogues, such as these, available free of charge to anyone and everyone, then request you all to please support us in our mission. We encourage you all to do check out our website and donate. We will be sharing the link for the donation page over the chat as well. Now, moving on to today's webinar topic, reducing industrial wastewater footprints and increasing water efficiency in industrial processes. Now, which is not only an ethical option, but also critical for sustainability. There are several ways for businesses to positively impact the environment, ranging from introducing innovative water recycling systems to optimizing processes to cut water consumption and so on. To moderate this webinar, we have with us none other than Professor Brajesh Dubey. Professor Dubey is presently the professor at Resource Recovery and Circular Engineering, Department of Civil Engineering. He's also a chair for School of Water Resources at Indian Institute of Technology, Kharagpur. He is well known globally as a waste and resource management and life cycle analysis and decarbonization expert. Today, he will look at many technologies and techniques that might assist industrial companies improving their water efficiency while reducing waste. Professor Dubey will address this topic with a panel of learned industry experts. So we have with us Saiba Gupta. She is the Program Associate, Sustainable Water Program at the Council on Energy, Environment and Water. She is currently working on the circular economy in used water management. She is engaged with urban local bodies for city-level planning for the reuse of treated water. She is an urban planner and architect with a background in urban environmental development policies. Next on our panel is Mr. Saurav Das Patnaik. He's the MD of Swachh Environment Private Limited, which is one of the holistic environment infrastructure companies involved in developing and operating one of the large water, wastewater, and solid waste management utilities under the public-private partnerships as well as B2B booth partnerships in India. He's leading the initiatives in building water and wastewater infrastructure and utilities under the ambitious national mission of Jal Jeevan Mission, national mission from Clean Ganga of the environment of from the government of India, and working closely with various state governments. Roshan Das, who's working as a professor in the School of Infrastructure at IIT Bhubaneswar and holding the position of Dean Student Affairs. He has about 19 years of experience in teaching and research, and he's teaching various courses that cover the knowledge of environmental engineering at both UG and PG levels. His research expertise include physiochemical and biological treatment of wastewater and pyromedication. Now, before we proceed further on this discussion, I would like to make a few announcements. This webinar is being recorded and will be uploaded on our website and YouTube channel. Please use the Q&A function for your questions to the panel. And we encourage you to please use this platform to raise as many queries to the learned experts that we have today on our webinar. Use the chat function to share your views and opinions, some reports, insights. Our panelists will also be sharing some links to whatever research or reports they have been working or the projects they are working currently. We will be sharing our panelists' LinkedIn profiles in this function as well, and you can use this platform for networking. So back to the panel and over to you, Professor Dubey.
Thank you, Akanksha, for the introduction. So we can get started right away. So in terms of, you can hear me okay, isn't it?
Yes.
You can hear me? Yeah, okay. So as we will have this panel discussion, so first we will have the panelists spend around 10 minutes or so giving an opening statement on different aspects of this water management, especially thinking about how to have better efficiency. We have called this panel topic as reducing and optimizing industrial water footprint. So from that perspective, like initial statement from each of the panelists, so and then we will have lots of Q&A and discussion and all that. To get started, I'll not take too much time, as we all know that water is a very important, from our day-to-day perspective, water is one of the most important thing that we should be worried about. And we are facing a huge crisis in terms of the water sector today, in terms of management of water, water quality issues, quantity issues, and all that. So in fact, one of the experts I've heard saying that, especially for a country like India, we don't have water in terms of resources problem. We have is actually water management problem. We are not really managing the water very well. So to get started, as the panel members have already been introduced, I'll invite Mr. Saurabh Das Patnaik and request him to give an overview from an industry point of view, and also he's very closely working with several ULBs as well on this subject in terms of how we can how different stakeholders, we are working in academia, industry, NGOs, how these different stakeholders can come together to achieve this reduction of carbon footprint. So Mr. Das Patnaik, the floor is yours for next 10 minutes, please. You are mute, sir. Please unmute.
Thank you, Professor. This is a wonderful opportunity to discuss and learn from different experts in this area. From a water utility perspective, where we are working with both industry as well as the various urban bodies and the JAL boards, we have been operating and building the infrastructure for water and wastewater in the cities and the villages as well, and operating them over the last few number of years. And what we find is a big challenge in the Indian context, and even for the economies which are emerging economies in Africa and America and South America, as well as Southeast Asia, the management of water remains a big challenge in terms of management of used water. I would not say it's a wastewater. I would say it's a used water, and reuse recycle policy are emerging in many parts of the country. Now, from a perspective of the subject matter, which you have very nicely elaborated and set up, the idea is to how do we reduce the footprint of our use and reuse cycle and essentially make it more efficient so that we can generate less energy and consume less energy per kiloliter of water. All of us know there are three fundamental important points as far as water and reuse policy is concerned. One is the cost of recycling the water and reuse water to a potable or non-potable use. In India, the non-potable use is the only prevalent way. The recycled water is not used for potable water, unlike in Singapore where it is blended. But coming back to the cost of water, now if I were to look at the cost of water as a plain water, as a river water, people assume it's free. And then the cost of chemicals and the power, and finally a cost of X dollars comes in per kiloliters. It could vary from country to country and depending on the indirect benefits and subsidies are available to the public at large. India, following the socialistic pattern of the governance, has been providing water almost at free of cost. Some cities have started to do some metering and also put a tariff policy, but by and large, the first 20 KL, I mean, even in a city like Delhi, first 20,000 liters per family, per connection is free, which means that 20,000 liters is free. And after that, you have some tariff, which is very telescopic in nature. But the point is, in India, the concept of reuse, recycle water, and then the billing of the water which is being reused and recycled is also very less. But in Delhi Jal Board and many cities like Chennai, the composite tariff policy is addressed. Suppose I were to use 1 liter of water or 10,000 or 1,000 liters of water, then the 40% of the weightage of the tariff will be given on the wastewater. Whether you recycle it or not, that is not the issue. But coming back to the industry at large, when you coming very specific to the industry at large, the industry is really because hungry for water, especially where India is building up large number of steel plants and power plants, and essentially every industry requires water. But coming back to the mining industry, where a lot of iron ore, steel, dolomite, and essentially all kind of minerals. A lot of mining water is being there, that is runoff surface water. Again, companies like Tata Steel and various companies are trying to look at recycling this water from the surface runoff water. But the point which remains here, what is the cost of recycled water varying from a location to location, varying from the effluent quality, and varying from the cost of the final output water. That is number one. Number two, cost of power. Now, all of us know the energy cycle, the food cycle, and the water cycle. The impact of and the biggest use of underground water in India is agriculture, it's not industry. But if you look at the cost of power to put water in your house, almost 35% of the cost of water which is landing at your house or to your factory is the cost of power, because water, unlike a sewerage, is a pressurized line. Now, if I were to add the cost of power for putting the water in your doorstep, and then the cost of the recycled water to be supplied to any industry from the sewerage waste, which is the municipal water, that again calls for $2 or $3 or $4, depending on what is the effluent quality, to add. So if I were to add $1, which is around 60 rupees as a standard cost, normally our cost in India for a bulk water supply is in the range of around 10 cents or maybe 8 cents. I'm just converting them into USD because it becomes easier for our international friends who are attending this. But it can be much lower. But just see the quality of water when you buy one water bottle or 1 liter anywhere else in the world. It probably costs you $1 plus somewhere else, whereas it's costing 8 cents a liter. So it's a question of how you market the water, how you manage the water, and how you price the water. It is very important. And what we are realizing it that reuse, recycle, especially in regions which are sparse with rain, which are not having rain-fed areas, catchment areas where rivers also are very less, or seasonal rivers, and the underground water, the table is also diminishing. We will have to per se come up with recycle reuse policy. I'm happy that Government of India has given certain guidelines for using municipal wastewater for industrial use by the process of tertiary treatment and providing the water to the industry. In India, specific to the states of southern states, which have got rain deficit, as well as the underground water table is very deep, the states like Tamil Nadu and Andhra Pradesh and Telangana have come up with such good plans. Even in the states of Gujarat and Rajasthan, people are talking about recycle reuse policy with the tariff model. And the tariff model, if I were to show my presentation some point of time, I think, Akanksha, if you can just go to the last 2 slides of the pricing, it will be very useful interesting. We did a survey on the pricing across the country. The last 2 slides, the last 3 slides, if you will look at. Yeah, last 3 slides. Yeah. Just go back 1 slide. Yeah. If you look at the slides, this is the Tamil Nadu state government, where the rates are in the range of around 150 rupees, which is about almost $2 per KL for industrial commercial organization. And it's going to, and this is a bit old report, but I mean, the tariff policies are changing, and tariff to a level of around 200 rupees per KL for industry is being applicable currently. And it is again depending on the end use. I mean, institutions are having less rates. And so that is by Tamil Nadu government and certain states governments have been very, very proactively working to recharging the groundwater, as well as the providing the used water from the municipality to the industry for at a premium. And that's what the Tamil Nadu government is creating, a very positive footprint situation where they are able to generate positive cash flow from industry. And industry would not have been using this water, they would have been using the river water, fresh water, instead of that the industries are using. But very important point here is, how do you transfer the wastewater from the municipality to the tertiary treated plant, and then from tertiary treated plant to the industries? And this is very important to see that there is a huge capital investment required for creating a network of collection, and then to transfer this water across some distances, and then supplying this water to the industry at large. It's not going to happen at the same location. Suppose you are a city of Nagpur, and then you have the industries which are for 50 kilometers away from the city, and most industries are city limits outside. So 50 to 60 kilometers of transmission and power cost is also very high. And that is why we need, when you do a budgeting of the exercise for costing, it will have to cover the cost of capital cost, the cost of operations, cost of insurance, and cost of different other costs, which will manage the entire situation. And no project is successful if it is not financially viable. So a financial viability will have to be looked at, and that's why there is a need for public-private partnership coming in from different state governments working to invest these schemes, and along with private operators who will actually deliver the KPIs for such usage. Now, technology is agnostic. We are a technology agnostic company. Different technologies are emerging across different, depending on what is the right technology to be used for the end use. And we are open to technology and partnering with institutions like IIT Kharagpur to actually develop solutions which will generate cost economics and also the lower carbon footprint. That's my take on this. I'm happy to learn and exchange my thoughts on this. Thank you so much, Prajesh.
Thank you. Thank you, Mr. Das Patnaik, for a very interesting coverage of, especially from the economics point of view. Like economics, as we all know, economics is very important, and putting that energy angle also in the picture. Many times we don't realize, we think that water is just like you collect and treat, but all the expense that goes into making that water potable. Really, thank you for putting that. And of course, we'll have a lot of questions and discussion in the second half of this webinar. So going forward, I'll request Ms. Saiba Gupta to kind of give us a perspective of recently she has co-authored as a report on how to bring circularity in the water management sector for ULBs, and Saiba, if you can shed some light on the industry as well, because that would be really good. So floor is yours, Saiba, for next 10 minutes.
Thank you for the question, Professor Dubey, and thank you for the introduction earlier, Akanksha. I'd like to sort of take off where Professor Das left off, where he highlighted the fact that circularity is going to be very important, and that's going to be even more significant for building urban resilience in Indian cities, given the declining fresh water. And this is going to be far worse in cities which are facing widening gaps between the supply and the demand, especially in the summer months. We've seen the cases of Delhi and Bangalore and Chennai recently, and every year. The circular economy approach to use water management, or commonly referred to as wastewater, here I'm referring to the municipal domestic sewage specifically, that would involve maximizing use water treatment and promoting its safe reuse. That could be for different non-potable purposes, be it municipal uses, irrigation of parks, road cleaning, or for private bulk users, such as in cooling of commercial establishment, the construction sector, industries. In cities, this can help combat the water stress by reducing the pressure on the freshwater resources, but it can also improve the water environment by improving the water quality of the local sources of water. Just to start with an overview of what is the situation of municipal domestic used water management currently in the country. Currently, Indian cities alone are generating over 72,000 million liters per day of domestic wastewater. Out of this, only 28% is actually being treated. So essentially, 72% of the domestic wastewater that only Indian cities are generating is not being treated. So it's being discharged into either land or surface water bodies, which is also one of the key reasons why the urban stretches of Indian rivers are the most polluted. Just to give an example of the Yamuna, only 2% of the river stretch passes through Delhi, and it holds 90% of the pollution load of the entire river. But by 2050, based on our projections, we will have over 96,000 million liters per day of treated wastewater available based on the current capacity that we have in the country. And we have projected that to the future to 2050. 96,000 MLD of treated wastewater is a significant quantity of water. And just to highlight that treating wastewater or reusing it is not just environmentally beneficial, but it is also financially feasible. That's very important since we're talking about circular economy. It's essential to highlight the economic value or the market value it can generate. So the amount of treated water that we have available in the country currently, and this is not in the future, this is currently already available treated wastewater. If this water was sold to different users, such as industries, irrigation, energy for reuse, it could have generated a daily market value of 630 million rupees. So this is in INR for the benefit of the international audience, that is 8 million USD. So this is daily market value. By 2050, considering the estimated amount of treated wastewater will increase, this will become 3 times. So this will be about 24 million USD. And this is based on the current market price of treated water and an average market price of treated water, not taking into account that the treated water being sold to industries or private users will actually be much higher than that sold to irrigation. So essentially, this market value will be much higher than this estimate. So this is absolutely the minimum market value, daily market value that we can generate. And also to get a sense of how much of an economic value it can generate, we use the irrigation sector as an example. Why? Because irrigation has the predominant water demand in the country. To establish how much of an economic value it can generate, so the amount of treated water, treated wastewater that we currently have available in the country, if all of that water was used for irrigation, it could have generated revenue worth 966 billion INR or 12 billion USD. So hence, again, just to highlight that there is a this is a financially feasible proposition, treating and reusing wastewater, which is a resource that we have at our disposal. And it's not just the irrigation sector, of course, like the focus is on industries. This water can be, the domestic wastewater, when treated, can be reused by the industries. For basic applications, it could be cooling and cleaning, or if the water is treated to a higher level, it can be tertiary level, it can be used for the primary process water as well. And to understand how Indian cities are actually performing in terms of how they're managing their wastewater, we undertook an exercise where we evaluated the performance of over 500 urban local bodies in the country to sort of evaluate the current performance in wastewater management. So this is their holistic performance in wastewater management, with, of course, reuse of treated wastewater being an essential component. And we've seen that despite the fact that many Indian cities are undertaking significant interventions to reuse treated wastewater, yet it has not been mainstreamed in the country. These are scattered examples that we hear quite often: Surat, Bangalore, Visakhapatnam. The concept, the very important point of water tariff was raised earlier. So just to give an example of Surat, the Surat Industrial Development Corporation is selling tertiary treated wastewater to industries for use at a price lower than the fresh water that they would have sold to industries. That is how they're generating the buy-in from the industry, because there has to be an incentive by the end user as to why should they even go for the treated wastewater. So one very essential point when it comes to setting the tariff for treated wastewater is that it has to be priced below less than fresh water. And there are, examples from Surat, from Visakhapatnam again, wherein they have, brought in the end users, in this case, the industry, to actually invest in the wastewater treatment process. Here again, it's important to understand that in India, largely the domestic wastewater treatment plants, or the STPs, are treating water mostly up to the secondary level, whereas industries and many other users that I mentioned require tertiary treated water. Now, there's also that cost of upgrading the technology to secondary to tertiary, which is also a significant cost. So just to give the example of a good practice in Visakhapatnam that has been implemented, they have brought in the end users, the ULB has brought in the end users of the industries that they're selling the treated water to actually invest in upgrading the existing STPs to tertiary treated water. And they're also recovering the costs that they're, undertaking in wastewater management by selling that water to the industries at a lower price. So again, bringing in the private users or the end users is also essential to make sure that the reuse projects can actually be implemented on ground, and especially so that there is cost recovery for the implementing authority. If there is no cost recovery, then in the long term, in a sustainable manner, the reuse of treated wastewater will not be, we will not be able to implement it in the long term. Another example, of course, is Chennai, a very known example, wherein the ULB is actually selling secondary treated water to the industries. A cluster of industries have set up their own tertiary treatment plants uh, on their own expense, and actually, further treating that water to tertiary level so they can reuse it. And in the long term, this has been profitable, more profitable to them than actually paying those very high industrial water tariffs. So on the whole, it's turned out to be a profitable venture even for the end users. And of course, there's been cost recovery for the implementing authority. Another very important aspect, of course, is these business models. Developing that market for the reuse of treated water is essential to realize its market potential and economic value. These business models, of course, include the aspect of cost recovery and pricing, but there's also the aspect of governance that needs to go hand in hand with business models and pricing, because that is very essential. As of now, currently, none of the Indian cities have a treated wastewater reuse plan at the ULB level. Since ULBs are the paramount authorities when it comes to domestic wastewater management, we need planning. Not only, of course, there are the national guidelines, there are 12 Indian states that have state level policies for treated wastewater reuse, but these policies have to be implemented on ground by the local governments. When we're talking about cities, it is the urban local bodies. Uh, what we are doing right now, we are working with urban local bodies in the country, in Maharashtra, Gujarat, etc., to develop treated wastewater reuse plans for them. And these are city-specific reuse plans at the ULB level that set targets, city-specific targets for wastewater treatment and reuse. Of course, they take into account both the quantity and the quality of water. Certain cities may not be water stressed, so they may not really have that incentive to reuse water. But at the same time, they will be facing issues of water quality. So both those aspects need to be taken into importance when we're talking about wastewater management. That is, it's not just about mitigating water stress, but it's also about the quality of the local sources of water in the city. And such a plan, what it would do is it will identify context specific users for treated wastewater. Based on the end users, we can define what is the kind of treatment technologies that we want, what are the kind of quality standards that these treatment technologies should be reaching up to, and also what are the kind of business models and the tariff structures that we want to put in place. Such a tool, I believe, can ensure that kind of circularity that we're trying to mainstream, and resource efficiency when it comes to a very important resource that is water. And wastewater very often is an underutilized resource. And I think this would be essential to ensure that wastewater is not wasted. I think I'll end here, but we can always continue, and I can
Yes.
go on and on about this.
Thank you, Saiba, for the wonderful overview, especially not only from the pricing side, but also circular economy and bringing all the stakeholders, like where the money will come, how why the industry will be interested to get the treated wastewater. So very good overview and then if you can put the link to the study that you are referring to all the attendees, as well as if you can put the link to the report, I think it will be helpful for everybody who is here. So taking from where you left, actually, you're talking about some technologies in terms of how to choose technologies. And we have Professor Rajesh Roshan Das from IIT Bhubaneswar. And I know that he has been actively involved in one of the big projects where several IITs, NITs, and other institutes are involved, where they are trying to test several pilots for not only for the secondary but also for the tertiary treatment. So, Professor Das, if you can give us some overview of what are the different technologies as a wastewater guru, if you can talk about what are the different technologies which is out there, and how academia, and I would also like you to talk a little bit about how academia, industry, and other stakeholders can work together to take things at the ground level. So floor is yours, Professor Das, for next 10 minutes.
Okay, thank you, sir, and good evening to all of you. So as sir has mentioned, so briefly I will tell you about our project. So before that, I visited several industries Also, industries, they are focusing on the use of the wastewater, like Ms. Gupta, she has mentioned, like we can use the wastewater, treated wastewater for the industrial applications, like we can call wastewater as the alternate source of water. Like the water scarcity we are facing, and also we will be facing severe water scarcity in the coming years. So that we know, all of us know, and a major area facing the water scarcity, and the industries, the water requirement actually that is also increasing depending on the different productions. Also the designs they are using, like we are focusing on the changing the design patterns and the green technology, that anyway somehow it is minimizing the water requirement, but anyway the water requirement is high, and that has to be utilized from the, that has to be make up from the treated wastewater. So I'll tell you about some technologies that we have developed, we have tested on the pilot level under the Saraswati 2. So we have a Saraswati 2 project, like Professor Dubey has mentioned. So in that we have several IITs, NITs, and different European institutes. So like 9 European institutes and 7 from India. So we have taken and tested some this pilot plants. So this pilot plant, the major objective was that we have to check whether the treatability of the wastewater is good enough, and we can reuse the wastewater. What are the sludge is being generated? Can we use for the biogas generation, or maybe we can use for the composting purpose? But major is the aim was that how we can reuse the wastewater. Like nowadays, we are deviating from the centralized facility to decentralized. When we're talking about the reuse of the wastewater, we cannot go always for the centralized facilities, because centralized is very difficult if you think of reusing. So in that way, like our project is focusing on the decentralized facilities, and in the decentralized facilities, how this wastewater can be treated, and what are the maybe cost economic evaluation we have done, life cycle analysis and the impact analysis has been done by also Professor Dubey, and what are the cost analysis also we have done. So accordingly, these technologies I can mention, like the USP and deammonification process. We have tried that USP along this, maybe for the nitrogen removal, that is from the wastewater, using this Anamox. That is a new technology, that how can we remove this nitrogen after the USP system. So this technology are not only limited to domestic wastewater. We, some of the technology are applied on the domestic wastewater, and some are applied on the industrial wastewater. But also, as for the results, we have obtained very good results. What we have obtained, we can see that okay. So these technologies, both it can be applied industries and in as well as in the domestic. But as Ms. Gupta has mentioned, this after treatment also, like this wastewater can be taken by the industry. So next we have another sequencing batch reactor. We have also checked, and RVC followed by sand filter and disinfection process. Then we have a sludge digestion systems, like using the ultrasonic treatment of sludge, and the Cambium sludge digestion system also we have checked. Along with that, some this natural systems like anaerobic digestion with photo bioreactors, and maybe the anaerobic digestion with the electrical conductive biofilters also it has been tested, and a nitrate removal using the EMB reactor, that is ecologically process, what is the natural process, that also we have tested. So although like industries mostly like Gupta mentioned, we need tertiary treatment because after secondary there is certain pollutants you have to remove. The industries, they have to do this tertiary treatment, maybe mostly focus on the advanced treatment systems or the advanced oxidations, like membrane, or maybe RO systems you have to use, or maybe sand filters you can use, so that you can actually utilize. So I have visited several industries also. When they're focusing on that, is also a mandate, like you cannot go away with these things. So when we're focusing on the reutilization of the wastewater, that is the different industrial applications, either you can use for the production, or maybe you can use for other requirements of the industry. Then you have to see that what are the requirements. Based on that, you can select a suitable technology. That is, you may not require these advanced technologies when you are utilizing for the some other applications, because the industries may be having different applications in the productions and other applications. So what are the applications. Based on that, we have to select the suitable technology. So based on that, the cost can be optimized. It is not necessary that always we have to go for the higher advanced technologies, which may lead to some additional cost. But anyway, the water is also less amount is available. Water scarcity is there, so we cannot allow all this water to be utilized, the fresh water to be utilized by the industry. So definitely, we have to see that how these industries can utilize the treated wastewater from the domestic sources, or maybe in the industrial, whatever the industrial discharges, you have to focus on the zero liquid discharge. Like what are the liquid, what are the wastewater they are generating, how it can be fully utilized using the different technology, maybe some reuse, maybe some recycling. We can do the organic removal, then we can do the nitrogen removal. So, like I have told, under Saraswati 2, we have checked all these technologies, and we're getting a very good result that in the pilot scale, and it also applied, some of this also applied in the industrial wastewater treatment. And both we have checked the nutrient removal as well as the organic removal. And nowadays, already we are in the process of improving the environmental conditions. Like we are going for the reusing of this wastewater, and our focus was on the decentralized processes. So in that way, I can say that the industries, it will be definitely helpful. Like what are the technologies we are developing, and automatically, if you have asked about the academic, what is the role of academicians in the industries? Definitely, because unless we test these technologies in the lab scale, in the maybe pilot scale, it cannot be directly applied to industry, because industries, different industries may be having different industry specific pollutants. And so that also to be taken care by the labs. Like in the academic institutes, you have to take care of that particular pollutant. What technology can help them to remove the pollutants, and also in that way, it is mandatory. Like we can say that it should be sustainable. It should not that okay, it may be removal, maybe initially maybe showing good. So life cycle assessment need to be done. So that way, if you think all these aspects, that is sustainability, or maybe the water uses or the reuse of the wastewater, so all these things, then we have to apply the suitable technology depending on the industry requirements. So thank you for giving me the opportunity to discuss these few things in this platform.
Thank you. Thank you, Professor Das, for giving the overview of that. And I think the link to that particular project that Professor Das was mentioning is already there on the chat.
Already shared, I think.
It's already shared. So you can always go to that website and learn more about those different projects. So there are some questions already there, and I now we'll start getting into the questions which is unanswered in the Q&A section, and then so I'll encourage all the participants, please go ahead and put your questions on the Q&A section. We are keeping an eye on chat as well, but it will be better if you put the questions in Q&A, so so that none of the question gets lost. So I'll get started. Maybe Mr. Das Patnaik, there is a question from Professor Jeet Sarma. Actually, he is based out of Toronto, a quite senior professor in the university there. And so his question is that there are in the wastewater we produce there's a lot of heat is there, isn't it? Higher than ambient temperature in the industrial wastewater.
Yeah.
Do we have examples of energy recovery from such wastewater, especially from the Indian example he's looking for?
Yeah, I am ex-Tata Steel. So I can tell you that in our system of blast furnace as well as steel making and the rolling mills, the ambient temperature depending on the blast furnace is more than 1800 or 2000 degrees centigrade. Obviously, at that point of time, for say the water is used for two things. One is for process, one is for cooling. So in the waste heat recovery, automatically the system is there in blast furnace as well as in the steel making and even in the rolling mills to capture the waste heat recovery system from the water, and then thereafter discharge the water to a lower temperature. Still, the temperature at that the discharge point, I remember in the steel plant in Jamshedpur, is around 55 to 60 degrees Celsius. But it is to further cool from the upper cooling point to the lower cooling point through aeration process, and the temperature is brought down. So this is an established process in the most of the heat recovery system from the water, both in the steel plant and aluminum smelters. Also, it is being used. I don't know, I'm not an oil person, but I'm sure the oil industry, the petroleum refinery is very important. We are serving a large number of petroleum refineries in Haldia and Paradip. Paradip has got IOC, Indian Oil Corporation, so more than 23 million tons of refinery, the refining capacity of crude, and in Haldia also around 13 million tons. And we are supplying the entire water and servicing. I find that they are trying to capture the heat as well as trying to ensure that the water is used for their different processes 7 to 8 times. So most of them are having ZLD systems in their plant, and they are not, because the norms are very strict nowadays in the pollution control norms. None of them are able to discharge anything which is beyond the limits. As a result, and especially large companies like Indian Oil Corporation, Haldia Petrochemicals, and power plants of RPG Group and different other power plants are actually ensuring the water for cooling is used 5 to 6 times, and the process is used for at least 7 to 8 times. But I have some challenges, let me tell you also at the same time, because we are water suppliers. When we supply bulk water, the water has got, this is a common denominator for everybody. Then everybody has their own plant, they have to refine it as per their requirements. I don't provide the water as per the specific industry requirements. So as you will appreciate in our Indian rivers, coastal rivers which are flowing into the coast, both Arabian Sea and the Bay of Bengal, the high tide and low tide has an impact of TDS, and the chlorides coming in during high tide. As a result, water gets high chloride, and the TDS levels can go up to more than almost 16,000, almost brackish water. So raw water which is getting into brackishness, obviously will have scaling in the boilers, and there will be severe problem in running the plant. So there will be need for pre-treatment services, and thereafter, then again the effluent which is coming out of the steel plant or the power plant or the petroleum refinery will have to further treatment with the ZLD process to ensure that minimum water footprint is there. I'm happy that large number of industries are really conscious about it. It's a directive from their corporate social responsibility and ESG groups to actually implement it. But at the same time, we have different small and medium enterprises, especially in the leather industry and the tannery industry. We are familiar with the tannery industry in India. Certain segments in the stretches in the river are having high pollution. You just mentioned, Saiba mentioned about the Yamuna in Delhi. So only 2% or 3% of the entire length, but it's creating has almost 60 to 70% of the pollution in a city like Delhi. And that's not only even urban, that is the domestic wastewater. There is a lot of other pollutants which are coming into the pollution which is coming. Though the Delhi has got now PCB norms and industries, harmful industries are being stopped, but there are many small grown industries which are not having adequate controls. And I think the contamination is happening from that point of view. I can also tell you, sir, example, in our canals, small canals, there are lots of, infiltration of pollution uncontrolled. And that's again is a big problem which we have. But coming to your subject matter, there are examples, and I can share with you Tata Steel's initiative. You can get it on their website also. They have been one of the pioneers, and most of the large steel plants in India and the power plants in India are actually following waste heat recovery process from the cooling water system. And that really reduces the energy cost by 20% or 25% also.
Thank you, Mr. Das Patnaik, for that response to the question. Saiba, there is a question on talking about in terms of when we sell treated water. That's from Vanita Prasad, as Akanksha also mentioned. She has been a regular attendee of our webinar. To sell treated water to industry, the cost of treatment increases dramatically while sewage treated by USP reactor-based STB is fit for irrigation, and the cost of treatment is low. And the other benefit is the nutrient is present in the form of nitrogen and phosphorus. What is the opinion she's asking opinion for all. So Shaiba, you can start, but others can chime in as well regarding doing a study to do a like a LCA analysis for both the use case or maybe for all the possible use cases of treated water.
Yeah, thank you for that question. I'll probably start with the first part of the question, and the second part, maybe the other speakers can chime in. It was mentioned by both the speakers that it's important to also understand who are the end users. So when we are developing a reuse plan for the city, we are identifying what are the end users, but we are also identifying what is their water demand and how much of that water demand can actually be met by treated wastewater. So if you have industry as a primary end user, we need to see that how much is their water demand in terms of the quantum of water. Most of that water essentially will be required at the tertiary level. So you will require higher level technologies, as you mentioned in your question. But we need to know how much should be the capacity of that tertiary level of treatment in the first place. So like mentioned by another speaker earlier, we don't need to set up a 100 mld plant to at the tertiary level. We can only set up, say, a 30 or a 40 mld treatment plant if that is the requirement for the city. So that is the first thing, understanding how much is the requirement based on who are our end users, what is the quality of water they would require. According to that, we need to define what is the treatment technology that we will adopt for that particular STP at that particular capacity of treatment. There was another question. I link it to this in terms of how can we also recover the O&M of these treatment technologies, because that is also very high in addition to the capex, of course. So when we're developing this reuse plan, we're looking at who are our private users from which we can actually recover the cost, because we cannot recover it from other municipal users. Our private users will essentially be industries, it will be the commercial sector, there will be malls, offices, the construction sector perhaps. So what we've done is we've seen that how much would be the operation and maintenance yearly annual cost of operation and maintenance of that tertiary treatment plant that is required to cater to these end users in the first place. And in order to recover that annual cost of O&M cost, at what price should the treated wastewater actually be sold to these users? And that again is based on the current price at which they are receiving fresh water. Because again, that has to be dependent on, it has to be lower than that. So it may be a different price for industries, it may be a different price for the construction sector. It has to depend on who the end user, it has to depend on what the level of treated water are we selling to them, whether it's secondary or tertiary. So based on analysis, we established a pricing structure for the treated wastewater, so that cost of technology upgradation or the O&M of that tertiary treatment technology that we now require can actually be recovered on an annual basis. That, I think is sort of my take on how do we even adopt appropriate treatment technologies in the first place.
Thank you, Saiba, for that. And regarding that LCA part, Professor Das, do you want to chime in? And if after you're done, I can add something there.
Yeah. Actually, you have done this LCA part, so you can better tell. But we have done this LCA, and we have found this USP after the USP treatment. Like we have found a good result, so that it can be utilized, and also like we have checked like the utilization of the wastewater. We are using for the now we are also using it for the horticulture and other purposes after the treatment after the USP. So definitely it will be good and cost effective. But details, if you want, you can add to these things or you have done the LCA.
Yeah. So Vanita said, as you know, like for any technology, especially in today's world, you have to look at its carbon footprint. Like any new technology you propose, what is its real carbon footprint? That's why I think probably you're asking about whether we have done LCA. But there are two aspects. LCA will give us the environmental footprint, and then there is LCCA also, which is the life cycle costing. As Professor Das mentioned during his talk, we also looked at the life cycle costing part. And then we have compared these different pilots in terms of their environmental footprint as well as the life cycle costing. And these reports will be there in the public domain. We are finalizing the report. It will be there on that website that I have listed. So based on LCA, as Professor Das also mentioned, we do find that out of 10 different pilots, since the those different pilots had different, I would say, the nature of treatment was different. Some places were more focused on looking for the sewage. Some places were more focused on getting the organics out or the nutrient recovery. So you cannot have like have one LCA study comparing everything. You need to group them under different categories. So again, to answer your question, like what is the opinion of all regarding doing a LCA? It's a useful, like you should do an LCA for all the possible use cases of the treated water. And when you're using, say, sewage water, which is treated from sewage, you are also avoiding the use of virgin, like a fresh water. So that also adds benefit to the environmental footprint. So taking all, but of course you have to take into consideration the energy requirement of all that, as Mr. Patnaik mentioned very beginning in today's webinar. So LCA does help us to take that holistic view and then come up with better comparison of different use scenarios, different technologies out there. So I think that possibly answer your question. And I would encourage all the participants who are there to ask your questions, chime in, give your put your thoughts in there as well. We each one of us are learning. We are not we are just on the panel, but just doesn't mean that we are only the expert. Each and every person who have joined the today's webinar, you have some experience. So we'd like to listen from you as well. So please feel free to share your experience. And then there is one more question, Professor Das, which is kind of targeted which is put to you, is that how are you benchmarking the water footprint technologies as related to productivity of the concerned industry? So yeah.
Yes, on that I can say that different industry, the industry specific or maybe production specific, like what type of products are there. So different products may be requiring different water, and also the industry also requiring different water. And the footprints, if you talk about, we can depending on the water uses, it is not only the water use, like the life cycle assessment of the product also, like what are the cost and how much is the end to life that is still disposal. So all these things we can take into consideration, and after that we can see that okay, how much water can be provided for a particular product. So in that way, it is not a specific product, we cannot decide on that one. But if you like say in general, like any product or any industry, if you talk about, so industry-wise, we can decide, okay, how much water is required. Out of that, how much water can be provided as fresh water, which is mandatory for certain industries, and how much water can be recycled. And that also, like, we can improve the systems, we can provide some new technology, and we can optimize the system so that the water usage can be reduced. So we cannot give a exact value for any particular industry or particular product, but like this we can define the things what particular industry can define based on the productions. And also we can do this benchmarking. We can make like there is certain government agencies, like they also evaluate the industrial productions, and they provide like this particular industry can be given this much water and this much wastewater also they have to utilize for their industrial productions. So in that way we can benchmark the system.
Actually, just to add to Professor Dash's views, up till now, the guidelines of the Government of India reuse policy, it is now mandatory for industries to use the sewage treated waste from the municipalities as the input to their industries for augmented supply, because they are not being given any further allotment of allocating for drawing of fresh water from the river or the groundwater. Now, the policy is not very clear on implementation. Like if there is a city like any municipality, or say maybe Kharagpur IIT is there, or maybe some other industries are nearby also, how do we connect the waste water coming out to the user groups in the different locations, maybe 30, 50, 60 kilometers away? And we found this problem in Tuticorin when we were talking to all the industries as operators. So they approached us at that Sterlite and HDW, and many industries were there. They said that we want to create a common ground for supply of wastewater so that you can utilize this wastewater coming from different streams. After a certain minimum criteria is being treated at their own source, and then the further treatment for augmenting the water supply in the entire city of Tuticorin is very scarce water, you know. Then we came up with finalized an option of financial funding of this project of around 250 crores. And we found that it is a combination of wastewater from the industry and desalination 20 mld for the fertilizer plants, and then blended use because there is no rain in that area. Similarly, another place in Tirunelveli in Tamil Nadu, an SEZ is there about 2,750 acres, and the nearest town is about 70 kilometers, that is Tirunelveli. So we thought that, okay, we can use the stabilized sewage water of the entire city of Tirunelveli and buy the water at a predetermined price and transfer the water, stabilized sewage water, not fully treated, to our SEZ, where we are the co-developers, and develop this cost. Now we found that treatment cost is basically high because of the transportation pipeline cost, which is costing almost 200 crores. And then the treatment is only 50 crores. And then purchase of the water is about 27 rupees or something like that per KL, stabilized sewage water. So municipalities also can, I want to bring out very important point here. It is applicable to most across the world. Municipalities have to earn money. The financial prudence and governance of municipalities, they are actually handing wealth, but they are not realizing the wealth which is there within their system. If they can sell the water by treatment, by using public finance and public and private operators, actually there will be very good value, especially in areas what the study of CEW has shown, where the water-starved municipalities or areas and states which are there. And the value will be created over a period of time. We are just at the cusp of this revolution. And I think in the next 3 years, you will find reuse, recycle policy being strengthened in each state, depending on their water scarcity or water balance of the state or district and ULBs. And there a pricing mechanism will emerge. State subject, because water is a state subject. So pricing, like an electricity regulatory authority is there, and is a state regulatory tariff commission is there. But in water, there is no tariff commission there. And as a result, this is the Tamil Nadu or Karnataka, they are having a board which is giving some pricing. But then it is not still followed properly. So I think we will be going towards the side, and India will face problems where we will have to, per se, it is not a luxury, it is a necessity for us, that water coming out of any system has to be captured at source, treated at source, and then transported. If that is happening, somebody asked a question in Jal Jeevan Mission. Jal Jeevan Mission is a true example where villages will be generating around 40 LPCD, 50 LPCD per day. But that is the way the calculation has been done. Now, if water which is being groundwater or fresh water being used by each village, is there a room? Some question was there. Do you think a decentralized model or a centralized model will work? Because villages are sparsely populated and spread out. So decentralized model, low cost model of stabilized sewage water, and then first level treatment, then the cluster based village level cluster based treatment. Thereafter, the water can be used for either ground recharging, which is the part of the JJM mission, or filling of the water bodies, or used for agriculture.
So there is an interesting, as you are talking, Mr. Daspatnai, there is an interesting question as well from Mr. T. Swaminathan, who is saying that when we set up the industry, we set it up looking at the freshwater availability, and whether there should be a policy now where the government approves based on the freshwater availability, where there should be a policy now where the reuse, recycle for the approval of the siting of the industry should be there. So we should also look at whether, I think the answer is of course, yes. We have to make it really work. We have to go that way.
Let me tell you, sir. I don't want to name the cities. There are multiple large industrial cities across the coast which don't have sewerage treatment plants. And industries have their own STPs, ETPs, and they are generating and they are treatment. But the city is 4 lakh population or 5 lakh population. must have STPs which could be utilized to augment the water supply or treated water supply to industries. And in municipality, there is an interplay between municipal and industry. People can generate cash flow by treating it. We have to capture the value at the source. If you can capture this value at the source, really the economics can work out. What Ms. Gupta is saying, very clear. And I think I saw her studies and what they have done in the 500 Indian states with annexures they have given. Very good thing. And I think your platform can collaborate, and we are happy to collaborate in such studies and even carry out technological pilots of say 2 MLD, 5 MLD, 10 MLD, which your IIT has done. And I think your School of Water Resources has done, championed some new technologies. We are happy to pilot those projects and fund some of these projects through a crowdfunding or bilateral funding.
So in addition to Mr. Daspatnaik was said, in Odisha also that there is Odisha Industrial Infrastructure Development Corporation, IDCO. So they also monitor this water usage, like industries, like when they're granting the approval of water requirement of the industries. I think they are forcing like it is by rule also like out of this water, the requirement they have to use 50% to 60% of the recycled water. So that is mandatory for the industry. So that they are doing because when some industry is applying maybe 7 liter or 8 liter of water for 1 liter of production, maybe think of a beverage, some beverage also like in that case also they are doing this study initially. Actually, how much really they need fresh water and other things can be made from this recycled water. If you may be aware of this thing.
Yeah, thank you. I think we are almost getting close to the time. So I think we lost Madam Saiba Gupta. Anyway, so one final question from me, as Mr. Daspatnaik, you were also talking about that many coastal cities doesn't have the sewage treatment plant. I have visited some cities which has a very good treatment plant but no sewage network. So I don't want to name that city.
You hit the nail on the head. The STP works in isolation of network. The network doesn't exist fully, or the network which has been made is the partial network. It doesn't capture the entire population, and that's the problem in our most of the Indian cities. And mentioned 28%, 30% being treated.
The plant was 10 MLD, and the flow coming was only 0.8 MLD, and it's a wonderful plant, very nicely done, SBR. But unfortunately, there is no flow. So I don't know how to solve that problem. They said that Swachh Bharat Mission 1 had the sewerage network. That time we could not work on it. 2 has the plant, so we made the plant, but we did not. We don't have the. Now we don't have money to connect.
I think our art lies in connecting the dots.
Yeah. So and there is a one question final out there. There's some final year student who's looking for ideas for some project in the work of wastewater and all that, industrial wastewater. You can always come in. I think based on today's discussion, you must have got several ideas, but you are more than welcome to connect with any one of us through LinkedIn. Mr. Daspatnaik, Professor Das, and myself, we are all available on LinkedIn. You can connect with us. We'll be more than happy to talk to you regarding projects. You can work on a variety of things. And like if you're really serious, Professor Daspatnaik can keep you busy for several years. Actually, he has lots of projects that some of my students are also working along with.
No, their students are doing fantastic. Real-time monitoring of river water and example of process improvements happened. Yes, I think it was very well appreciated by the government as well as by us. I think we want young brains to come in and chip in to build a very good, strong, robust ecosystem. We are at the, I think, very exciting time that we are in the cusp of a new revolution of wastewater or reuse water, what they call it. I think the wealth will come out of that. The wealth of the churn of the Sagar Manthan and as well as the wealth of thought, which will really get implemented now. I'm very excited.
Thank you. Thank you. So I think for the interest of time, we can wrap it up now. Usually we try to keep it along 1 hour because this goes on a YouTube and also Be Wastewise YouTube channel and their platform. So people can watch it later on as well. So I think now the floor is yours, Akansha. So
Thank you
please go
so
ahead.
much. Thank you so much, Professor Dubey. Thank you so much, Saurabh sir and Professor Das. I think the conversation can be endless, and I'm sure there'll be many more questions cropping up slowly and gradually as and when people are sinking in the kind of content they have been getting from all of you. So thank you so much for taking time out, the panelists. And we are also thankful to all the attendees who've been part of this webinar. As I mentioned, this webinar is being recorded and will be uploaded on our YouTube channel and on our website soon. And if you like to stay updated on future events, and probably the next calendar year is already booked with Professor Dubey doing many more waste dialogues on a monthly basis with us. So please do subscribe to our newsletter and follow us on our social media. Thank you all and good day to everybody.
Thank you.
Thank you. Thank you.
Thank you.